In this demo, we will show you how you can use Swift to migrate the containerized application WordPress from IKS Classic cluster to IKS VPC cluster, and we will also set up the DR for the IKS cluster using Swift. Now let's take a look at both the clusters and the application that we are going to migrate. This is the source IKS cluster running on the classic infrastructure, and it's located in the Frankfurt region. Let's take a look at its dashboard. Here we have deployed the WordPress application inside the WordPress namespace. We can see the workload objects listed here. There is one deployment WordPress, which is the front end of the application. And there is one stateful set MariaDB, which is the back end of the application. Now let's check the storage that the app is using. We can see here that there are two PVCs that the app is using to store the application data, and both are using the IBM Classic block storage. Swift provides you an option to convert the storage and choose another for the replicated app on the target cluster. During the replication, Swift will perform this conversion and also replicate all the KTS objects that are a part of this app and create them onto the target IKS cluster. Now let's access the application. This is the Blogger website that we are going to replicate today, and we've created a sample post here for the demo purpose. Now let's check the target cluster. This is the IKS cluster running on the VPC Gen 2 infrastructure, and it's located in the Dallas region, which is different from the production region because this is the DR use case. Now let's access its dashboard. We have created an empty namespace WordPress here where we will replicate the WordPress application, and also created a secret inside it, RackWare try secret. Now this is needed to configure access to the registry where the try image is located. Try is a custom image deployed with the Swift product. During the replication, Swift will create an instance of it on both source and the target cluster for the staging purpose. So for that, you need this secret pre-created. In the current release, this is a manual step, but in the upcoming release, we've automated it and Swift will create a secret for you. Now let's take a look at the Swift server. This is the CentOS 7-based virtual machine created on the IBM cloud in the Dallas region. So for DR use case, we recommend you that you create Swift server in the same region as your DR cluster, because if some disaster happens on the source cluster, then you don't want to lose the Swift server and the backups it has. Apart from this, we attached a 20 GB storage to this server. This is needed only for the DR use case to store the local backup of your application. But for migration only use case, this extra storage is not needed. We've installed the Swift application onto this server. Now to access the Swift server, you need to copy the IP address of the virtual machine and append the Swift dashboard to it, and you'll be landed onto the login page. During the installation, we have already set the password for the default admin user. And if you want, you can add multiple users to the Swift after logging into the Swift server. If you need any help with the Swift operations, you can download the guide from here. For now, let's log into the Swift server. Since we haven't yet added the clusters to the Swift, we are landed onto the cluster administration page. Let's add both the clusters to the Swift. Let's add production cluster first. Let's add it. Similarly, let's add the DR cluster. Add it too. So during the step, Swift will gather all the clusters metadata like the namespaces and the other KTS objects. Once the cluster is discovered, you can expand it and check the details that the Swift has discovered. So let's expand the IKS production demo, which has our application deployed. Here you can see the summary of the cluster, like the version of the KTS and other environment details. If we go to the namespace, we can see the list of namespaces that are present on the production cluster. We can also expand any namespace and check the list of objects that it has. By default, it lists the pod objects. If you want to see the list of another objects, then you can select the kind here. So there are two PVCs that are present on the WordPress namespace on production cluster. Now, the next step while setting up the DR is to configure Swift storage. So for that, you need to create a storage pool. Let's give it a friendly name, backup pool. And here Swift will list all the block storage devices that you can add to the pool. And if in case you are not sure whether you are adding the correct device, you can always connect to the Swift server over SSH and cross-check the details there. Let's add this device and create the storage pool. It has been created. To check its details, you can expand it and check the summary here. Now let's go to the DR policy section and create one DR policy. Let's provide a name to the policy here. Now there are three types of policies you can create on the Swift. Pass-through is meant for the migration and the recurring sync use case. If you want to take a backup of your application, then you need to create the stage 1 policy. And for DR use case, you need to create the stage 1+2 policy. Now it's a combination of stage 1 sync and the stage 2 sync. Stage 1 sync basically will pull all the applications metadata and the data onto the Swift server, and stage 2 sync will push the application and objects onto the target cluster. Now both these can have their separate schedules. Let's provide the schedule for the stage 1 first, and for the stage 2, let's select it to execute after stage 1. If you want to receive the alerts for DR sync completion, you need to provide the email ID here. And after you provide it, you can also enable this option to receive DR alerts only if something fails. Now let's create the policy. The policy has been created. Now you can directly apply the policy and provide the sync options to do the initial migration and the recurring syncs. But we recommend you that you first do the migration using stage 1 and stage 2 syncs and then apply the policy to those jobs. So now let's start the stage 1 sync job. Here you need to select the stage 1 sync type. Provide these source details here, which is the production demo where the application is deployed. The next option is whether you want to replicate all the apps from your namespace or whether you want to sync a particular app. So if in case your namespace has multiple applications and you want to sync a particular app or a particular object, then you need to provide the details here. And during the replication, Swift will identify all its related objects and will sync all of them. For now, let's select all. Now let's provide the name for the target, which will be a local backup. The next set of options are the try options. So you need to provide the IP type and the ports for the try service that gets created during the sync. If you have already whitelisted this port range in your firewalls, then you can auto select the ports. Since we haven't done any extra settings, so we will be providing specific ports here, and these ports will automatically be opened in your cloud by IKS. Let's provide the job name here, stage 1 sync. Start the stage 1 sync now. You can see here that the stage 1 sync has started, and we can see the live checkpoints here. Let's wait for the sync job to finish. Stage 1 sync job has now finished. Let's start the stage 2 sync job. Here you need to select the source as the local backup, WordPress backup that we created in the stage 1 sync. Then provide the target name, which will be the IKS DR demo. Select the namespace where you will be replicating the application. Let's select the storage class that you want your target to use. Provide the zone where the target volumes will be created. Let's provide the try ports for the try service to be created on the target cluster. Provide the friendly name for the stage 2 sync job. The advanced options, Swift provides a lot of customization options that you can apply for your replicated app. Like if you want to change the type of your service, then you can select the service here and provide the new type. And if you want to change the port of your application service, then you can do it here. You need to select the service whose two ports needs to be changed. Then you need to select the port that you want to change here and provide the target port name. And after adding this rule will be applied by the Swift during the replication. Similarly, if you want to include or exclude a particular volume during the sync, then you can do it here. There are also a lot of options available for the pre-post scripts and the pre-post YAMLs that you can apply before and after the replication. For now, let's start the replication. Stage 2 sync job has now started and it is rediscovering the target cluster to get the latest status of the targets cluster. Let's wait for the stage 2 sync to finish. Stage 2 sync has now finished. Let's go to the target cluster to check the app. So this is the dashboard of the target cluster. Let's check the services and access the WordPress app. We can see here that the migration was successful. Now, before applying the staging jobs to the DR policy, let's create a sample post here on the source application for the Delta Sync demo. Let's give it a name here, Delta Sync, and publish the post here. The post has now been created. Now let's go back to the Swift server and apply the DR policy to the staging jobs. Select the policy, apply. Select the jobs here. Add both of them. Provide the fallback configuration and just click on the apply to apply the policy. Now within few moments, DR policy will schedule the staging jobs. So for that, go to the sync administration and all replications page. We can see here that the DR policy has initiated the stage 1 sync. Let's wait for it to finish. DR stage 1 sync has now finished and DR policy has initiated the stage 2 sync. Let's wait for it to finish. First iteration of the DR policy has now finished and the next will start after an hour because we've created an hourly policy. Now let's take a look at the target application. Let's access it. Here we can see that the new post has appeared here and the Delta sync was also successful. Now let's go back to the DR policy. Now, if in case some disaster has happened in your production region and you want to failover the policy to make the DR side active, you can do it by clicking it here. And if there is any outstanding data that hasn't been synced to the target, then Swift will sync the data to the target. And since there is none, so Swift will only change the state to the failover. And to run the failover in the test mode, you need to check this box and click on the failover. Here we can see that the policy's state has now changed. If you want to fall back the policy, you can click on this button and click on the fallback sync. Since the policy was failed over in the drill mode, it didn't perform any sync operation and simply changed the state. But for a real failover, Swift will sync the data from the local backup to the production cluster. And in this way, we've migrated the application and set up the DR. Thank you.